Hello, my dear young friends. My name is Srinivas, known to be BS Rao. Welcome back to C Level Physics, meant for Foundation, cbse, icse, igcse, neet, JEE Main, and Advanced aspirants. I requesting all the audience to please subscribe channel C Level Physics and click on bell icon to get regular updates. Please don't forget commenting on my videos, share my videos. Okay, today's topic is motion under gravity. See, by name itself, motion under gravity. By the name itself, motion of body under the influence of gravitational force caused by the earth. Am I right? So here, we know that every object is being pulled by earth towards its center and causing some acceleration to every object while moving. Am I right? That itself acceleration due to gravity. Acceleration due to gravity. Am I right? See, as earth is pulling every object towards its center, what is the direction of acceleration due to gravity? Always vertically downwards. Always vertically downwards. Am I right? We know that equations of motion, v equal u plus at, s equal ut plus of h square, v square minus v square equal to 2as. These are all known as equations of motion, right? Which can be applicable for every object which is under uniformly accelerated motion or uniformly retarded motion, right? But here also, if acceleration due to gravity is constant, here also those equations can be applied. Am I right? Okay, but if acceleration due to gravity is constant, we have to make some assumptions, right? What are the assumptions? Let us see. See here, assumptions. Air resistance is neglected. Air resistance. Suppose apart from gravitational force is some other resistive force like air friction also there on the body, then we have to consider acceleration because of that resistive force also. So then a problem becomes complicated. So to avoid that complication, what shall we do means we have to neglect air resistance, right? So that's what here written. Air resistance is neglected. That's our first assumption. Now what are the other assumption means here? We assume that body to move through small heights near the surface of earth. Why? Because here there are so many factors which influencing acceleration due to gravity. What are the factors means? We know that if you go away from the earth's surface, acceleration due to gravity decreases. If you go deep into earth, then also acceleration due to gravity decreases. Because of difference in shape of the earth also, acceleration due to gravity decreases. We know that earth is bulged at equator than at poles. So because of this difference in shape also, there is some difference in acceleration due to gravity at equator and poles. We know that the acceleration due to gravity is maximum at poles and minimum at equator, right? Because of rotation of earth also, acceleration due to gravity changes. So here, likewise, so many factors influencing the value of acceleration due to gravity, right? So we have to consider some assumptions to make the acceleration due to gravity is uniform or constant, right? As acceleration due to gravity changes with height, with altitude, right? We have to assume that when body is dropped or projected up from the surface of the earth, we have to assume that it is moving through smaller heights. Then there is no much change in g, almost remains constant. So that's what here shown. What is that? We assume that body to move through smaller heights near the surface of earth. While going up or while coming down, a body is always assumed to move through smaller heights near the surface of earth. That's what second assumption, right? Next, here acceleration because of gravity. So that's the reason why A is numerically equal to G. What is the symbol for acceleration due to gravity? That is G. So A equal G. Usually it is 9.8 meter per second square. Otherwise, in most of the sums you will be given 10 meter per second square. Right? G value, which is constant. In feet, that is in practical unit, this word in SI unit. Right? In practical unit, same can be written as 32 feet per every second square. 32 feet per second square. So same can be written in cgs. If it is 9.8 meter, here 980 centimeter per second square. Why? Because 1 meter equal to 100 centimeters. So 9.8 into 100, that is 980 centimeter per second square. Otherwise, if g equal to 10 meter per second square, 1 meter is equal to 100 centimeter, that is 10 into 100, that is 1000 centimeter per second square also. In CGS, this is what in CGS, system. This is what in SI system, right? In fact, what is the significance of acceleration due to gravity means? A means what? A equal to delta V by T. You know that acceleration equal to change in velocity per time. Am I right? Now, what is the change in velocity here? 9.8 meter per second square. No, that is same can be written as 9.8 meter per second by second. 9.8 meter per second by second. That is equal to 9.8 meter per second means that is second square. Right? So what is the significance here means? A equal to, in fact, A means G, that is equal to delta V by T. That is, what is the change in velocity per each second? That is 9.8 meter per second. Right? Earth causes every moving object to undergo a change of 9.8 meter per second in velocity. Am I right? That is a change in velocity per every second caused by Earth in case of every moving object. Right? What is that? 9.8 meter per second per second. Suppose if it is accelerating, if body is accelerating near the surface of Earth, what does it represent means? In every second, the increase in velocity delta V equal to 9.8 meter per second. In every second. The same body is under retardation while going up against gravity. In the same second, in every second, the decrease in speed or the decrease in velocity is 9.8 meter per second. In every second. That is the significance. Am I right? Okay. So here, G always pointing vertically downwards. As I told you, Earth attracts every object towards its center. So therefore, G always acting vertically downwards, right? So as per sign convention, here it is positive x, negative x, positive y, negative y like that, right? Suppose if G is vertically downwards, what is the significance? What is the symbol? What is the sign convention? That is A is negative, right? Vertically downwards, negative. So A equal to minus G in case of body going up or body coming down. So irrespective of direction of motion, acceleration due to gravity always negative, minus G, right? As gravitational force is acting vertically downwards. If it is vertical upwards, if at all that gravitational force is vertical upwards, then it can be positive, but it is not the case like that. Why? Because Earth attracts every object towards its center, that is vertically downwards. In fact, that is negative, vertical downwards means negative z axis. So therefore negative A equal minus G, right? Here we have to go with the sign convention while calculating sums. What are the points in sign convention? Let me show you here. See, this is what reference line. Reference line. What is reference line means? It's a line passing horizontally through point of projection of the body. See, this is the point of projection of the body. A line passing through point of projection horizontally is said to be reference line here. It may be surface of the ground or top of the tower also. See, this is what dotted line, a reference line, maybe surface of the ground or top of the tower, right? So from which your body is going up. Going up means along a positive y-axis. In case of positive y-axis, all quantities are negative, all quantities are positive except G. Why? Because irrespective of direction of motion, G always vertically downwards. So G is negative always. See, here body is going up from the reference line. See, this is what reference line. From this reference line, body is going up. So U means here initial velocity. V means final velocity or instantaneous velocity. Means velocity at any other instant. Initial velocity in the sense, it's the velocity of body when our observation starts. That is when time t equal to 0. So this is the velocity of body when time t equal to 0 our observation starts. Initial velocity. This is what instantaneous velocity. In fact, it may be final velocity also when t equal to t, time t equal to t, right? So here, this is what t equal to 0. This is what velocity u. So u is positive, body is going up, u, initial velocity u, positive, displacement covered also positive, acceleration g is negative. Why? Because g is always vertically downwards. That's why g is negative. Right? Suppose the body is going up and again because of gravity retracing its path like that. Retracing its path line, going up and again comes down. That second line showing separately here to avoid the confusion. In fact, body goes up and retraces along the same way. See, it goes up and retraces. It goes up and again retraces along the same way. But to avoid the confusion, the two lines are shown. See, this is going up again coming down, right? So here, as long as body remains above the reference line here, u is positive, s is positive, u positive, s positive, a is negative. Time always positive. No sign convention for time. It always positive, right? If at all body moving vertically downwards below the reference axis. See, this is what reference line or reference axis. So below which body is moving vertically downwards. See, therefore u velocity negative, displacement negative, right? Acceleration due to gravity, that is negative. So this is what sign convention. Okay, above the axis means all quantities are positive except g. Below the axis means all quantities are negative, including g also. So here one common point is there in both cases, that is, in both cases, which quantity is negative here? G is negative, right? Here also negative, here also negative, here also negative. Let us see equations of motion in case of freely falling body. What do you mean by freely falling body? Means if initial velocity of body is 0. See, if this is the body, right? If this body is simply dropped without projecting, simply dropped like, if it is dropped like that, it falls vertically downwards, right? Simply dropped like, right? Without projecting, if it is dropped, then it becomes freely falling. See, at the time of releasing, the velocity of hand becomes initial velocity for the dropped object. See, at the time of dropping, I am not at all shaking my hand, simply drop. Am I right? So therefore, whatever the velocity of my hand by the time when body is released from the hand, that becomes initial velocity for the dropped object. Right? So in this case, I am not at all moving my hand, right? By the time when body is dropped. Therefore, the velocity of my hand by that time when body is dropped, that becomes initial velocity for the object. So here, in case of freely falling body, initial velocity is 0. Am I right? It is not at all projecting. So therefore, initial velocity u0. See, this is what the freely falling body like. Freely falling body. So this is what reference line from which body is dropped. See, this is what reference line. Here, what is the initial velocity? u0, right? U equal to 0. Now, see the sign convention. Here, body is moving on vertical line below the reference axis. So therefore, displacement is negative. Time always positive. Am I right? What about acceleration? A equal to plus, is it plus g or minus g? G always negative. So therefore, minus g. Right? u0, s negative, a negative. Now see those general equations of motion. V equal to u plus at, s equal to ut plus of 8 square, v square equal to u square plus 2as. Now first equation, 1 implies 1 equal to, see, u equal to 0 there. So v equal to u plus 8. You know that v equal to u plus 8. That is 0 plus a becomes minus g into time. So v equal to minus gt. This is what transformed equation. First equation in case of freely falling body. See here, v comes with negative sign. T always positive, here G negative. Therefore, V negative. V negative means velocity at some other instant other than T equal to 0. That becomes final velocity or instantaneous velocity. That becomes negative. Of course, here velocity is 0. Later on, because of gravity, body gains some velocity which is negative. Why? Because it is moving below the axis, below the reference axis. So, instantaneous velocity is negative. Now, coming to second equation, number 2. Number 2, S equal to ut plus half h square. S equal to ut plus half at square. Am I right? That is 0, u means 0, 0 plus half into a means minus g into t square. That is S becomes minus half g t square. S becomes minus half g t square. Am I right? So here t is negative, positive, g is negative. So the displacement comes with a negative sign. Why? Because displacement, why it is negative means below the reference line, body is moving on vertical line below the reference line. Therefore, S negative, V also negative. Right? S negative, V also negative. Okay. Alright. Now coming to third equation, that is number 3. Number 3, V square equal to U square plus 2as. V square equal to U square plus 2as. Here, V square equal to U 0 plus 2 into A becomes negative minus G. S also negative. S also negative. S also negative here. Right? If V is unknown, don't take negative sign for unknown. Suppose here V is subjected means V is unknown. Don't take negative sign for unknown. Here also comes. So A negative, S also negative here. Am I right? Why? Because it is moving below the axis. That is V square equal to 2gs. 2gs. Right? This is the required transformed equation. Am I right? Okay. Here one more point in sign convention. What is that point? Don't take negative sign for unknown quantities. Don't take negative sign for unknown quantities. If at all it is really negative, it comes in the end. Okay. So we are not supposed to take negative sign for unknown quantities. Right? So take all quantities with proper signs. Take all known quantities with proper signs. But don't take negative sign for unknown quantity. If at all it is negative, it comes with in the end. With negative sign in the end. Right? Now second case, when body is projected vertically downwards. Here in this case, body is not at all dropped but projected. See, my hand comes into motion like. If this is projected downwards, my hand must be come into motion. See, like. So by the time when the chalk piece is released, the velocity of my hand becomes initial velocity for this dropped object. So in this case, my hand comes into motion to release this body. So therefore here, initial velocity is other than 0, non-zero. See, this is what reference line. So initial velocity u not equal to 0 means there is some finite initial velocity for the dropped object. So therefore it becomes body projected vertically downwards. As body moving on vertical line below the axis, displacement and g is negative. So displacement negative, g negative, u non-zero. Now first equation becomes number 1, v equal to u plus at. So v equal to u means 0 plus a means minus g. T always positive. Right? Sorry, u not equal to 0. U not equal to 0. U not equal to 0 and downwards and negative. Non-zero but negative. Non-zero and negative. So minus u. V equal to minus u minus g. See, both terms are negative means both terms negative. So v ultimately negative. So instantaneous velocity or final velocity comes with a negative sign. Both terms are negative. Right? Now coming to second equation. Second, S equal to ut plus half h square. s equal to ut plus of at square, right? U non-zero but negative, so s becomes minus u, am I right? Minus u, t positive plus half into a means minus g into t square. So s equal to minus ut minus plus or minus half g t square. So this is what second equation of motion, that is s equal minus ut minus half gt square. Here both terms are negative, therefore s also negative. Why? Because here body moving on vertical line below the axis, right? So s is negative. Now number 3, what is the third expression? V square equal to u square plus 2s. V square equal to u square plus 2as. That is v square equal to u negative and non-zero. So minus u square. Of course, minus u square becomes plus u square also. But as per sign convention, u negative and non-zero. Plus 2 into a means minus g. S minus s. Of course, v also negative, but if it is subjected, it becomes unknown quantity. So don't take negative sign for v square as it is subjected, right? So v square equal to minus u square means, again v square equal to minus u square means plus u square. Plus or minus minus or minus plus of plus. See, minus or minus plus of plus of plus 2gs. Am I right? Okay. Here, of course, if it is make it subject, v becomes root over u square plus v becomes plus or minus root over u square plus 2gs. Right? Here we have two signs, values with the two signs, positive and negative. But as per sign convention, instantaneous velocity becomes negative. Instantaneous velocity becomes negative. Why? Because it is below the axis, moving below the axis. Take with negative sign. Alright? Okay. Now coming to third equation. Third case, body projected vertically upwards from the ground. See, this is what reference line means, surface of earth from which body is projected vertically upwards. Right? This time my hand must comes into motion to release the object. Am I right? Therefore, initial velocity of the body is non-zero, not equal to 0. There is finite initial velocity for the object. If body wants to go up, it must be projected. It must be projected upwards. So my hand must comes into motion before releasing the object. So whatever the velocity of my hand, by the time when body is released, that becomes initial velocity, which is non-zero. That is positive. Why? Because it is moving above the axis, reference axis. So u is positive. Now s also positive. Right? As body moves up, s also positive. But a becomes minus g irrespective of direction of motion. Irrespective of direction of motion, g always negative, right? Time always positive. Now coming to first equation number 1, v equal to u plus at. v equal to u plus at. That is v equal to u means non-zero but positive. That is plus u, right? Plus a means minus g into t, right? v equal to u minus g. But here v means velocity at any other instant except t equal to 0, right? So it may be positive or negative, even 0 also, depending upon time. Why? Because here g is constant at a given place, initial velocity constant, but time it is not constant. As time goes on, what happens? This second term g into t increases and becomes equal to u also at some instant. In that case, v becomes 0. Let us see. If gt less than u, Suppose if t equal to 0, v becomes u. T equal to 0 means initial instant. G into 0, that is u minus 0, that is u. V becomes u. Similarly, if gt is less than u, the second term gt less than u, v becomes positive. Implies v is positive. V is positive in the sense body is still in ascending motion, right? Still in ascending motion, like is going up from here, is going up, didn't reach highest point, right? So body is, what is the reference here? If gt, second term gt is less than u, v comes with the positive sign. V comes with the positive sign means still body is going vertical upwards, right? Now if gt becomes u, the second term gt becomes u. As time goes on, what happens? T increases, then product gt also increases. Sometimes at some other instant gt becomes v also, u also. That is, if gt becomes u, then v becomes 0. V becomes 0. What is the inference here? If gt becomes u, u minus gt cancel with each other, we left with v equal to 0. What is the inference here? Body reaches highest point. See here negative sign is there. Because of that negative sign, what is the inference? Body is under retardation while proceeding vertical upwards. So body retarding means speed decreases and becomes 0 at highest point. That's what the case here. So gt equal to u means v becomes 0. Yes, body reaches highest point. Here. Right? That is what? Highest point. Reaches highest position or point in its path. Right? Now if gt exceeds u, means gt is greater than u. Here it is positive sign, here it is negative sign. But here the value of negative sign is more than positive sign, means v comes with the negative sign. That is, v is negative. V is negative in the sense body is under descending motion. Means body goes up, reaches highest point and retracing along the same path, but same can be shown in next line like that. Okay. See here, this is initial direction, this is the final direction after retracing. Am I right? So v is negative in the sense body is descending motion, means going up, reaches highest point and further retracing. That is the inference, right? Okay. That's what background behind this equation. Am I right? Now coming to second equation. What is second equation? That is, what is second equation? See, second one, s equal ut plus of h square. Ut plus of 8 square. Am I right? Ut plus of h square. Now s becomes, see, s is unknown, for example. Don't take with negative sign for unknown quantity. S equal to u positive or not? Yes, positive but non-zero. So positive means u or plus u. Ut also positive, plus half into a means minus g into t square. Right? That is, s becomes ut minus of g t square. This is the transformed equation for this case. Second equation. S equal to ut plus ut minus of g t square. Am I right? Ut minus of g square. Here also, of g square at time t equal to 0, what happens? Second term becomes 0. That is, s equal to ut. S equal to ut. Again t also 0 here. So s equal to 0. So if time t equal to 0, substitute t equal to 0, s becomes 0. Means body is at the point of projection over at time t equal to 0. If object square less than ut, what about the situation here? See, if object square less than ut, if object square less than ut means s becomes positive, implies s is positive. S is positive means, see, this term is less than this one. This is positive, this is negative, but this is less than this one. Therefore, ultimately S comes with the positive sign. S positive means body is still going up. Body is still going up. That is the meaning. Am I right? Now see. Now that is next point. If object square becomes equal to ut. See the second term, as t increases, second term, this product also increases and becomes equal to ut also. In that case, s equal to 0, right? If object square becomes equal to ut, see object square becomes equal to ut, so both will cancel with each other. We left with s equal to 0. Implies s equal to 0. S equal to 0 in the sense, what is the significance? Total displacement is 0 means, when it possible means body reaches point of projection. Body reaches point of projection. Right? That is S equal to 0 means body reaches point of projection like that. Right? That is the meaning. Body reaches point of projection. Am I right? In which case object square becomes equal to ut. S becomes 0 means particle reaches the point of projection again. That is the meaning. Now, if object square is greater than ut. Object square is greater than ut. When it possible, object square is greater than ut. Not in this case. In next case, when body is projected vertical upwards from the top of the tower, you will know in next case. Now coming to third equation. What is the third equation here? V square equal to u square plus 2ax. V square equal to u square plus 2ax. Am I right? Third equation, that is number 3. V square equal to u square plus 2ax. Am I right? Now v square becomes equal to u positive plus u square, that is u square, plus 2 into a minus g into s. Right? V square equal to u square minus 2gs. V square equal to u square minus 2gs. Right? So this is what third equation. Okay. Now let us see in fourth case. Okay. Now case number 4, in which body is projected vertically upwards from the top of the tower. I shall see this word tower of height capital H. A is the top of the tower. Now here from this top, a body is projected vertical upwards with some initial velocity. So here also initial velocity is non-zero. If velocity is not given to the body, it won't go up. So velocity is must at time t equal to 0, right? So here initial velocity is non-zero. Now as this is the point of projection, a horizontal line passing through point of projection becomes reference line. See, this is what reference lines from which body is projected vertical upwards. So u pointing upwards above the axis. Therefore u positive, right? Okay, u positive. Now a equal to minus g. Whether body going up or down, a is minus g. Now replace one by one equations of motion. First one. See, first one, v equal to u plus at. So v unknown, instantaneous velocity v unknown, u known. So known means going up, that is positive. So plus u, otherwise u, plus a becomes minus g. That is v equal to u minus g2. Right, v equal to u minus g2. When time t equal to 0, v becomes plus u, means initial velocity. So as time goes on, term gt increases, product gt increases. As t increases, product gt increases. and becomes to u also at highest point, right? Now see, if gt less than u, gt equal to 0 means we equal u naturally. If gt is less than u, gt less than u means this is negative, this is positive. So positive value is greater than negative value. What is the resultant? V positive. That is V is positive. Final velocity is positive. So if gt is less than u, V becomes positive. What is the meaning? Still body is going up. Still body is going up. That is the meaning. Still body is going vertical upwards. Like that. Am I right? Means body lies between A and B. A and B. Body lies between A and B. See, this is what A, this is what B. Final point or highest point B. Means where is the what is the location of body here when gt is less than u means body lies in between points A and B. Somewhere in between points A and B. Right? Now, if gt becomes equal to u, see gt negative, this is a positive, but both are of same magnitude. So gt u, both are equal means cancel with each other. V becomes 0. So instantaneous velocity V is 0. V 0 means what is the reference? Body reaches highest point. Body reaches highest point. Body is at B. At D means highest point. Am I right? Okay. Now, if gt is greater than u, if gt is greater than u, then v becomes, see this is what positive, this is what negative. So negative value is greater than positive value. Therefore, v automatically negative. So v is negative. V negative means body reaching highest point, and furthermore what happens? Body retracing. That is the name. See like that. Body is going up, right? From here, body is going up from here, and again crossing the highest point like that. Crossing the highest point, right? So body lies between B and C. So between B and C, V is negative. V is negative. So body lies between B and C like that. So body lies between B and C. Point B and C. Right? Somewhere between B and C. Here V is positive means body lies between A and B. Between A and B. V is 0 means body is at highest point B. Am I right? Okay, that is the meaning. Now coming to next equation, s equal to ut plus of its square. Number 2, s equal to ut plus of 8 square. Of 8 square. Right? That is s becomes u positive, t positive plus half into a means minus g into t square. So s equal to ut minus half gt square. S equal to ut minus half gt square. Here also this is with positive sign, this is with the negative sign. First term positive, second term negative. Right? Now what are the obligations here? If of gt square less than ut, of gt square less than ut means negative value is less than positive value. So s comes with the positive sign. Implies s is positive. S positive means body is above the reference line. S positive means body lies above the reference line. That is implies body lies above the reference line. Body lies above the reference line. Somewhere here or somewhere here or somewhere here or somewhere here, somewhere here, somewhere here. Right? Somewhere here also. So like that. See like that. Like that. In between these two positions. In between these two positions. Somewhere in between these two positions. Right? Right? Next. Object square greater than ut. If object square greater than ut. See, second term object square, negative term is greater than positive term. Then s becomes negative. Implies s is negative. S negative in the sense body lies between reference point and ground. Right? Implies body lies between a reference point and ground. Alright? See, between these two points like, see, right, this is what A, this is what C, between AC, that is between AC, A and C, between A and C. Between A and C means what is the sign for displacement? Negative. See, this is what initial position, this is what final position. A line segment from initial to final. Negative or positive? Negative. So S equal to minus H. S equal to minus H. See, initial position. This is the final position. So whatever the path, neglect total path, but take a line segment from initial position to final position. From initial to final. So this is what a line segment drawn from initial to final. Yes, that is H on, but with negative sign. Why? Because lying below the axis. So S becomes minus H. S becomes minus H. So S becomes minus H. Height of the curve. Right? So this is what S equal to ut plus half H. So coming to V square equal to U square plus 2as. See. Right? Number 3. V square equal to U square plus 2as. Now V square, suppose unknown as it is subjected, V square equal to U positive and non-zero plus U square, that is U square plus 2 into A means minus G into H. S means S. S, as I told you, S equal to 0, S may be positive, S may be negative. Now only we came across the 3 points. S, it may be positive, it may be negative, it may be 0 also. Am I right? So leave like that. Why? Because for a while it is lying above the axis, reference axis. For a while it is lying below the axis like that. So therefore S, it may be positive, it may be negative, it may be 0 also. Therefore I am leaving with positive sign only like that. That is V square equal to U square plus or minus 2GS. 2GS. So that's about, friends. Okay. For today, signing off. Thank you, friends.